This is question 21 from the 2022 GCSE Mathematics Higher Tier exam and tests our understanding of circle measures. If you find this video helpful, please consider leaving a like, a comment, sharing this video, and subscribing to our channel for more content like this. We've been given 3 circles with a radius of 4 centimeters, whose centers are horizontally aligned, and we've been asked to find the total area of the shaded regions in terms of pi. A sector of a circle is a slice of a circle. It's the portion of the circle's interior enclosed by 2 radii and the arc that connects them. To identify or calculate properties of a sector, we need to know 3 main parts: the radius, the arc length, and the central angle, formed where 2 radii meet. A minor sector represents less than half of the circle, while a major sector represents more than half. A segment of a circle is the area bounded by a chord, which is a straight line connecting 2 points on the circle, and the arc connecting those same 2 points. Just like sectors, segments come in 2 sizes depending on where you make the cut. A minor segment is less than half the circle, while the major segment is more than half. Answering this question is a lengthy 6-step process. First, we need to find the area of each circle. Then, by forming a right-angled triangle between the center of the circle and the point of intersection between the overlapping circles, we can find the angle formed at the center, that we can then use to find the area of the sector, triangle, and segment inside the circles. To finish, the shaded area is the difference between the area of the circle and sum of 4 segments, which we can subtract to find in terms of pi. To begin, we need to calculate the area of 1 circle. The area of a circle is equal to pi multiplied by the radius squared. We've been told that the radius of the circle is 4 centimeters. So pi multiplied by 4 squared gives us a value for the area of 16 pi centimeters squared. The question tells us to give our final answer in terms of pi, so it makes sense to keep all of our calculations in terms of pi as we proceed. By forming a right-angled triangle from the center of one circle to the point where the circles intersect, we can calculate the angle formed at the center of the circle by the intersecting circles. The hypotenuse of the right-angled triangle is the radius, so its length is 4 centimeters. The base of the right-angled triangle is half the radius, so its length is 2 centimeters. For a right-angled triangle with a hypotenuse of 4 and a base length of 2, we can use trigonometry to calculate the size of the angle labeled alpha on our diagram. First, by labeling the sides hypotenuse, opposite, and adjacent. The appropriate trigonometric ratio is the cosine ratio. So, the cosine of alpha is equal to the adjacent side divided by the hypotenuse, which is 2 divided by 4, or 0.5, giving us a value of alpha equal to the inverse cosine of 0.5, which is 60 degrees. By forming a sector of a circle, where the angle formed at the center is double 60 degrees, which is 120 degrees, we can calculate the area of the sector by using the formula. Area equal to theta divided by 360 multiplied by pi r squared, where r still has the value 4 and theta is 120. Substituting these values gives us 120 divided by 360 multiplied by pi multiplied by 4 squared, which can be simplified to give us 1/3 of 16 pi. Inside the sector is an isosceles triangle with 2 equal sides formed by the radius of the circle with an angle of 120 degrees. We can find its area, which is given by the formula 1/2 of the product of A and B multiplied by the sine of theta, where A and B are the two sides of equal length, and theta is the size of the angle between them. The radius is 4 centimeters, so A and B each have the value 4, and theta is 120 degrees. Substituting these values gives us 1/2 of 4 squared multiplied by the sine of 120. And the sine of 120 is equal to 1/2 of root 3, giving us 1/2 of 8 root 3, which is 4 root 3. We can subtract the area of the triangle from the area of the sector to find the area of the segment. So the area of the segment is equal to 16 thirds of pi minus 4 root 3. The question asked us to find the area of the shaded region, which is the area of the circle less 4 times the area of the segment we just calculated. The area of the circle is 16 pi, and the area of the segment is 16 thirds of pi minus 4 root 3. And so, the shaded area is equal to 16 pi minus 4 multiplied by 16 thirds of pi minus 4 root 3. We can simplify this by expanding the bracket to give us 16 pi minus 64 thirds of pi plus 16 root 3. And by expressing 16 pi as a fraction with a denominator of 3, 1/3 of 48 pi minus 64 thirds of pi plus 16 root 3. And finally, by collecting the pi terms, we get 16 root 3 minus 16 thirds of pi, which gives us the final answer 16 root 3 minus 16 thirds of pi centimeters squared. Answering this question successfully relies on our understanding of circle area formulas, trigonometric ratios, and the areas of sectors and segments. So the area of the shaded region in terms of pi, and the answer to this question is 16 root 3 minus 16 thirds of pi centimeters squared. Please follow us on Instagram, TikTok, and Threads for daily maths content.